Our search for cosmic clusters begins not through the eyepiece of a telescope, but in the cockpit of an interstellar spacecraft. Our mission? To traverse the galaxy and find out why clusters are so valuable. Why they are keys to unlocking the mysteries of the stars. Our first stop? The Pleiades, the most famous star cluster of all. 440 light-years from Earth. Known since antiquity, it contains 1,000 stars, though only a handful can be seen from Earth.
The Pleiades are the so-called Seven Sisters, a bright, easily noticeable grouping of stars in the winter skies. Well, it turns out only 6 of the stars are easily visible. You can see 6, and really sharp-eyed people can see 8 or 9 or 10. Rarely have I met anyone who can see precisely 7 stars. So maybe in antiquity, there was a star that was considerably brighter than it is now, but it has faded since then, so now there are only 6 easily visible stars. There are actually hundreds of stars in the Pleiades, perhaps up to 1,000.
We circle the Pleiades in search of clues that can reveal the secrets of the universe, because clusters hold the key to understanding how stars are born, how they live and die, the secrets of creation. Like all clusters, we see that the stars in the Pleiades are so close to each other, they are all virtually the same distance from Earth.
Of course, the stars in a cluster are not all exactly at the same distance from us, but they're so far away that the slight differences in distance are really pretty small. They're inconsequential. A nice analogy is viewing a stadium full of people from a blimp high above. From the perspective of the blimp, most of the people are at about the same distance.
Most of what we know about stars, their size, weight, and age, comes from figuring out their inherent brightness. But you can't judge a star's true brightness without knowing how far away it is. That's where the cluster comes in.
The fact that all stars in a star cluster are basically the same distance from us is very important. It gives us a sample of stars where we can actually see what the intrinsic, real brightness of these stars are. Unless we know these stars are all the same location, we don't know whether we're looking at a bright star that's far away or a dimmer star that's close to us. There's no way to tell. But in a cluster, all together, you can see that.
The same rules that apply to stars in the sky also apply to cars on the road.
What we have here are 2 cars, same make, same model, so we know the headlights on each car are exactly alike and equally bright.
From where I'm standing here, one car's headlights look just like the other. That makes sense. But now, let's make these cars act like stars in the universe. Same stars, but at different distances. Okay, Amy, back it up. Look at these headlights now. The ones over there are much dimmer than the ones here, even though we know they're the same. This is the inverse square law. If that car is twice as far away, then the headlights are 4 times dimmer. If it's 4 times farther away, the headlights are 16 times dimmer, and so on as far as you care to go.
But sometimes, a light that appears to be dimmer actually is.
This flashlight and the headlights are just like stars in a star cluster. The flashlight next to the headlight looks dimmer, and that's because it is dimmer, not because it's farther away. A dim star next to a bright star in a cluster looks dimmer because the star itself is dimmer, not because it's farther away.
This way. If an alien wanted to learn how humans live and die, but they could only watch us for 30 seconds, they flew by Earth, and they took pictures of millions of humans. Even though they couldn't watch a single human live and die, as a group they could piece together our story. They looked at some babies, they looked at older people. A star cluster is just that.
What would it have been like for the sun when it was part of a cluster? To find out, we file a flight plan for a place where stars are forming in a cluster right now. We're headed 1,500 light-years from Earth to the Orion Nebula, which looks like a fuzzy star in Orion's sword. Up close, though, it's a spectacular light show.
The Orion Nebula is one of the great stellar nurseries that we know of. It's forming stars right now. And if you were to fly through the Orion Nebula, you would see a whole bunch of stars, but near the middle, there are 4 particularly bright stars. They form a configuration called the trapezium. And if you were to fly past these stars, you would see these 4 newly formed, brilliant stars and a whole bunch of little guys all floating around. It would be a wonderful journey.
We head toward the trapezium stars, the 4 brightest in a cluster that's a hectic laboratory of star formation. Thousands of other stars have formed or are in the process of forming. But as it's happening, scientists believe the cluster is imposing a kind of birth control on the whole cycle.
Only about 10% of the mass of a cloud which will form stars actually becomes stars. So why is it that so little of the matter in a cloud actually turns into stars? What we've come to believe now is that there may be a feedback process. So once you form stars, they feed back on the cloud, acting like a thermostat, and actually limiting the amount of star formation that can form. In the trapezium cluster, you've got those 4 massive stars that are producing enormous amount of ultraviolet radiation, as well as winds that stream into the surrounding area, and they will affect the gas that wants to form stars. So even though you have another 1,000 stars forming around the trapezium, the star formation rate in that area is being affected by the ultraviolet radiation and the winds from those massive stars.
If nebulas are the stellar nurseries of the cosmos, then clusters are their grade schools, where stars stay together until life and the galaxy drives them apart. But it's clear not all clusters are alike. We're due now to encounter clusters that make up some of the most extreme environments in the entire galaxy, where stars are so massive, they are on the verge of blasting themselves into oblivion. When it comes to star clusters, one of the first things most people want to know is, what's the biggest? Which ones really stand out? It's no different than looking at a big city. You want to know about its tallest buildings, its most distinctive landmarks. If there's an Empire State Building of star clusters, we'd have to travel 10,000 light years to find it. It's called Westerlund 1, a supercluster with a total mass 100,000 times our sun.
Westerlund 1 right now holds the world's record for the biggest known young cluster. It has about 100,000 stars, and what's really odd is for a long time, we didn't even know it was that massive. Astronomers have known about Westerlund 1 for a long time, but only about 5 years ago did we first get a glimpse of all the stars in the cluster, because that's when we had infrared detectors that could peer through the dust in the galaxy that's situated between the Earth and the cluster.
Recent advances in infrared astronomy revealed a space only 6 light years across, packed with a thick population of stars. The biggest and brightest are galactic freaks, supergiant stars, in a range of sizes and colors from blue to red and even yellow.
The blue supergiant phase and the yellow and red supergiant phase represent phases during the lifetime of a massive star. They start blue, they become red. In some cases, they go back and forth between blue and red as the outer layers are lifted and we see deeper to the hotter material. In between the red and the blue phases, they're yellow, and so we call them yellow supergiants.
The sun, which so often is called an ordinary star, is tiny when compared to supergiants of any color.
Suppose our sun, which is over 100 times the diameter of the Earth, were scaled down to the size of this little yellow pinhead here, less than 1/8 of an inch in diameter. So we're really scaling down the sun a lot. In that case, the largest stars, the red supergiants, would be about the size of this telescope dome behind me. They're huge compared with the sun, and yet the sun itself is already huge compared with the Earth.